I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
medicine,
nature,
or
space,
Time.
the brain,
Life. The universe.
This week, can science help us to quit our vices? Do animals have accents like us humans do? And how big can a planet get? We're taking on the science questions you've been sending in. Hello, I'm Chris Smith, and this is The Naked Scientist.
The Naked Scientist podcast is powered by ukfast.co.uk.
Let me introduce the fine-brained panel of people who are going to help answer your questions this week. With us is Jess Wade. Now, she's a physicist at Imperial College in London. And Jess, you work on LEDs. What do you do with them?
I use light-emitting diodes based on carbon materials, so organic semiconductors, not conventional semiconductors. And with them, we're trying to do some really cool things with the polarization of the light that's emitted so that we can use them for next-generation displays.
What does that mean in practical terms, polarization of the light? How does that work?
So normally LEDs emit unpolarized light. So basically it's a light wave that's traveling in all different kinds of directions. And we're trying to control the polarization so that it can kind of sneak through filters and quarter wave plates and optics that are already in screens so that we can increase the efficiency of the screens and also do some really clever things with communication.
How far away are you?
Not that far away. I think I've done it. I've nailed it.
You really? So
Yeah.
we're going to see why is this going to look better though? What's going to be amazing about the displays we get with this?
For the displays that you get, if you have an OLED display already and you're very, very rich and they're very beautiful, then it will make it more efficient. So you'll stop pumping so much energy in, but you'll get the same light out.
So your power bill will go down?
Power bill should go down. The colours will remain as beautiful because organics make beautiful coloured screens.
Wonderful. Thank you, Jess. Jess Wade from Imperial College. Sitting next to Jess is David Rothery. He's from the Open University where he's a planetary geologist. Is one planet not enough for you, David?
No, it's not. I'm bored with this. No, Earth is a wonderful planet and I learned my trade on Earth, but I'm working mostly on the planet Mercury now in preparation for a mission which we're launching very soon to go to Mercury.
That's Bepi Colombo.
That's Bepi Colombo, the European Space Agency's mission.
And you're involved in that?
Hi, I'm leading the Surface and Composition Working Group for ESA. And I have a bunch of PhD students making geological maps of parts of the planet. So when we get there, we can understand the context for the new observations that we'll be making.
We'll find out a bit more about Mercury from David later on in the programme. Bianca Jupp's a neuroscientist. She's at Cambridge University. You specialise in addiction. I understand that you did a talk on addiction, but you did it in a pub. Now, there's a venue for you. What, you preaching to the converted?
I'm always happy to give a talk when they pay me in beer, so that was definitely a bonus. Yeah, I very much enjoyed that, but it's a good chance to actually establish this idea that addiction isn't a bad thing. The stigma associated with addiction is a really, really detrimental part of society. And by giving a talk about addiction in a pub, you can really reach everyone.
It's probably a very abused term, though, isn't it, the word addiction?
Most
because
definitely.
people talk about being a chocolate addict or things like that. But when you're actually really addicted to a drug, it's quite a different thing.
Most definitely. And again, this is where a lot of the stigma of addiction kind of stems from, this whole idea that, I might be addicted to adrenaline or I might be addicted to chocolate, as you say. But really, addiction is technically, we define it as continued use despite adverse consequences. And so as being from Melbourne in Australia, and I really, really love coffee, I can never be addicted to it because really the only adverse consequences are probably a little bit too jittery.
There's something about Australia and coffee addicts because that I got my coffee problem when I lived in Australia and I blame Australia for that. Bianca, thank you very much.
Not a worry.
Bianca Jupp, who'll be talking about addiction later in the programme. Also with us, Jacob Dunn. He's from Anglia Ruskin University. Now you work on animal communication.
Hi, Chris. Yes, I do. I work on animal communication. I mainly work with primate vocal communication. So we study other primates.
Can you do an impression?
I can do a howler monkey for you.
Go on then. That's very good. Can you do any others?
What else could I do? I could probably do a spider monkey scream.
Go on then. That's fabulous. We're liking that. It's 10 out of 10 for that. Brilliant. Okay, thank you. Anyway, before we dive into the questions that you've been sending in, we have got a quiz running throughout the programme, which is an opportunity for you at home to take part. We're going to give you clues as we go through the hour, so we'll slowly drip feed you more clues as to what the mystery animal is. So we're calling this the Who Am I quiz. Here's your first clue. This is what I sound like. No, it's not my son having a belching competition in the back of the car, which does happen on a daily basis on the way to school. That's the sound that this thing makes. More details later, but now is the first question. Right, let's kick off with this one. This is for you, David Rothery, and it's come in from Sarah.
We always hear about the hunt for life on other planets. Could life theoretically exist on a planet's moon?
So moons is a good home for life. What do you think, David?
Well, in this solar system, Sarah, moons are probably the best place to go looking for life. You shouldn't restrict your imagination of where life can exist to the surface of a body with a blanket of air, like planet Earth. We think life on Earth began at the interface between warm rock and salty water, the floors of the oceans. And we have at least 2 moons, one of Jupiter and one of Saturn, where we've got oceans sitting on top of tidally heated rock, with a possibility of chemical reactions between the water and the rock. And that's the setting where life could exist today. If you took the right microbes from the Earth and put them down there under the ice on Europa and Enceladus, life could hang on there, could exist. So the question is, did life ever get started there on its own? And that's what we don't know. But we know from the recent Cassini mission to Saturn that flew through the plumes from Enceladus, where the ice is jetted to space. It's got all the ingredients. It's got organic molecules, tiny rock particles, molecular hydrogen. There is a metabolic pathway feasible on the floor of Enceladus's ocean. So, yes, life in the internal oceans of moons, very much a thing to look for.
Jacob?
This is probably a naive question, but would we know what we were looking for? Would we know what life looked like?
Well, life is anything that will reproduce, undergo a Darwinian evolution, and piggyback on chemical reactions. If we can see an atmosphere or ocean chemistry that's kept out of equilibrium, we tend to suspect it's because of living processes. But difficult, I agree.
I just wonder if we might see some of the sort of early reactions that aren't life per se, but maybe the kind of precursors. Would we know?
Yeah, that's a good question. Can we get clues as to how life got started on Earth in these places?
The fact is, there are so many organic molecules around in the cosmos, which are not the products of life, but you've got simple amino acids which exist already. So if you want to find something that says life did this, you've got to look for more and more complex molecules. I think we need to see the chemistry in action. And I guess if we ever do find what might be a biosphere, pinning down whether it's due to living processes or something that's not quite living might be difficult.
So, Sarah, the bottom line is that these moons could play home to life. It's just whether or not it's got started yet. David, thank you. Now, Jacob, you put your head above the parapet. We've actually got Joanne on the line for you. Hello, Joanne.
Yeah, hi there.
What would you like to ask Jacob?
Are there any animals that have vocal ranges between the sexes? For instance, in our species, the males typically have a range about an octave lower. So is there any evidence for this?
Jacob?
Hi, Joanne. Yeah, that's a really good question. So there is obviously a difference in the frequency in the voice in humans, as you rightly say. So male voices tend to be about 75% lower frequency than female voices. Interestingly, this is something that, as we all know, doesn't happen all the way throughout our lives. In other animals, I know most about primates, but it's true in some other animals as well. Whether there is a difference or not between males and females seems to be related to the mating system. So in those mating systems where males compete more ferociously for access to females and have harem groups and so on, there tends to be a more exaggerated difference between the males and the females. And in other species that are perhaps monogamous and there's not such high levels of competition between the males, then the difference between the males and females tends to be less. So in answer to Joanne's question, yes, we do see this in other species, and it seems to be linked to the competition between the males and the mating systems.
Happy with that, Joanne?
Yeah, but in those cases, is there evidence of it changing during the animal's lifetime like it does in the humans then?
Yeah, again, that's a really good question. And yes is the answer, through the same mechanism. So the reason that the voice frequency drops in male humans is because it's linked to testosterone. The vocal folds, as they lengthen, anything bigger vibrates at a lower frequency. So as you get longer vocal folds, your vocal frequency gets lower, and therefore you have a lower pitched voice. And that growth in the vocal folds in boys and in the male voice is linked to testosterone. And through that same mechanism in other animals, as they get higher testosterone, their vocal folds lengthen.
I did notice in my dog, I had a puppy, and he had a yap that, as he turned into a big strapping great Labrador, became much more of a bark. So that's sort of going along with, that's the size thing, isn't it, Jess?
Can I ask you a question about bonobos? So I was recently in San Diego and I met this phenomenal scientist called Amy Parrish who researches bonobos, and they're a matriarchal society rather than a patriarchal society like chimps. So there, do the women have deeper voices because they're in charge, or do they have higher pitched voices?
That's a really good question. So it's more complicated than there only being mating systems in which a male has a harem or monogamy. There are lots of other different kinds of organisations. Sometimes you just have one female that has multiple males. It's called polyandry. And very often among primates and lots of other animals, you have this polygynandry, multiple males and multiple females in a sort of promiscuous arrangement. And so the communication system will reflect that. Some species like bonobos and spider monkeys as well, the females are pretty hardcore and they will beat up the males. And that will be linked to higher testosterone and lower vocal frequency. Yeah.
So they will. So the bottom line is, Jess is right, they're going to have a deeper voice. There you go, Joanne. I hope that answers your question. Thanks for calling in. And if you'd like to put a question to the team, it's @NakedScientist is the Twitter handle. You can email chris@thenakedscientist.com. Jess, this question has come in about light from Amy, who wants to know, how does a laser's colour affect how it works? I guess you could rephrase that in terms of what the colour means in terms of its application. What can we do with it?
So we can excite loads of different things with lasers, and we actually use them a lot in physics to look at different molecules and to understand stuff about different atoms. But actually, I thought about this in a different way, which was how do we generate different colours of laser light? And there it's really, really interesting. So to get a laser at all, we need some kind of thing that will be the kind of lasing medium. And then we need something to excite this medium. And then we need a bunch of mirrors. And to get a laser to work, we basically excite an atom or a gas or a dye up to an excited state. So we take the little electrons that are usually in their ground state, put them in an excited state. They're not very happy there and really quickly jump down, emitting a photon of light. And the mirrors are there to bounce that photon around a lot of times, so it keeps triggering and emitting more and more photons until eventually there are enough of those to escape through one of these mirrors. And you can generate this kind of light in lots of different ways. So sometimes we do it with gases, sometimes we do it with dyes, sometimes we do it with semiconductors, like the LEDs that I work with. And all of those different things can get different colours. But actually, when you've got a laser light at the end of it, you don't really know what the origins of it were unless you built the laser yourself, because the colour is just, it's monochromatic, it's one wavelength, and that's what a laser really is.
But we can choose the colour depending on the application, can't we? So people can use the certain wavelengths of light, certain colours of light, if they want to, say, cut tissue. If they want to use a laser for surgery, you'd use a different colour, presumably, if you wanted to cut steel.
Exactly. And the laser light, the colour of the light determines the energy that laser light will have. So you can use a really high energy laser, a kind of ultraviolet or a blue laser, or a lazy infrared laser if you want to look at something that isn't quite so high energy to be able to excite it.
And Donna Strickland, who got the Nobel Prize for her work on lasers, her breakthrough was making the pulses exquisitely short. Why did that matter?
She wanted to be able to generate huge amounts of power over a very short increment of time. And they actually had huge innovations later in doing things in the eye. So these were really, really short pulses of very powerful lasers that then you could use to treat conditions that were in your eye. I think the most amazing thing about Donna Strickland, other than this innovation in laser technology, was that she did this while she was a graduate student. And this was the first paper that she ever published.
The first paper she published won her a Nobel Prize.
Which is just so neat. And then went on to have a really phenomenal career in Canada. But what an inspiring and wonderful thing to do. And for every PhD student listening there, you've got a huge responsibility now.
Yeah, it's got to keep the side up now. OK, thanks very much, Jess, for that one. Bianca, this question's coming for you from Ben.
Hi, Naked Scientists. I'm at Thorpe Park and I'm wondering, why are people such adrenaline junkies?
Thank you, Ben, at the theme park there. That definitely gets the prize for the best location-dependent question that we've had sent in. So, Bianca, can you help us? Why are some people hooked on adrenaline?
Yeah, it's a very good question. And I definitely have to put my hand up and say I am a bit of an adrenaline junkie. I love snowboarding. So this is actually a personality trait that some of us have. And it's because basically we find doing risky things rewarding. Essentially, what happens when you do something risky is you get a release of this neurochemical known as adrenaline. So again, adrenaline junkies. The body creates this because basically it's priming us for this flight or fight response. So making us ready if we need to run away in case of danger or if we want to stand and fight. Now, for some people, for these sensation seekers, adrenaline is particularly rewarding. And so we have another neurochemical in the brain known as dopamine. And anytime we do something that's rewarding, we get an increase in the level of this neurochemical, dopamine. And so people who are adrenaline junkies, we think what happens is they basically, anytime they do something that releases adrenaline, it increases the level of this neurotransmitter dopamine and it feels good.
Is that learned or is that something they were born with?
No, it's something they were born with. Yeah, it actually, to be fair, it's roughly 50% heritable, this behavioural trait. So
you get a family of thrill seekers.
Most definitely.
And how do you know it's definitely genetic and it's not that if you've got parents who are really, really, they're out there go-getting, doing exciting things, that they just immerse you from a young age, you get no choice and you get hooked on adrenaline because of your family environment?
Yeah, certainly. But we do actually see this in animals. So we have...
Really? Thrill-seeking animals?
Thrill-seeking animals, yeah. So I actually work on rats. And we look for this behavioural trait because it's really interesting because being a sensation seeker actually increases your risk for addiction. Because we're not quite sure why. Is it something about your underlying biology? Or is it because you're more likely to take drugs because you're looking for that kind of novel, exciting experience associated with taking drugs or booze? So we actually see that in our rats, some of them prefer novel environments. So if you put them in a maze and they have exposure to one side, if you then open up the other side of the maze and they can then go and explore it, some rats will bolt straight into the other side and spend more time exploring it than others. And we see that this is heritable amongst our rats.
Wonderful. There was a story that was published in an Indian science journal not so long ago, and these two men were described, these two cases, and they had been professional, I suppose you could describe them as professional drug abusers for decades. And they got to the stage where nothing was really working anymore. So they had been written up because they were persuading snake charmers to get king cobras to bite them in the tongue.
My goodness.
Because they found this elicited a state of near nirvana for these people for a couple of hours, and they would wake up all woozy and say, well, that was wonderful, can you do it again? But the medical profession are fascinated because they want to know how these people can survive mega-lethal doses of cobra venom envenomated into their tongue.
Oh my goodness.
And actually they're fine. So there's clearly something about the addiction that's happened in these people, and they've obviously changed the way their brain chemistry works because of drug addiction, which has then led them to be less vulnerable to one of the most potent venoms we know. So fascinating case. Jacob?
No, I was just thinking of this from kind of the other end of the kind of evolutionary spectrum, if you like, because you can study behaviour from the very kind of proximate end and you can study behaviour from the very ultimate end, and thinking of sort of why do these sorts of things evolve. It's really important to understand exactly what the mechanisms are as well, but I find it interesting to ask why these things evolve. And thinking of human behaviour in that sense, why people go out of their way to jump off a cliff with a parachute on their back or whatever it might be, part of the explanation might also be because it somehow enhances your reproductive success. You're showing off, you look cool, you look sexy, and you're more likely to...
Only if it works.
Only if it works, exactly.
It can be very, very counterproductive, and you can look very unsexy if you really fall flat on your backside. Is that really the case, though, Bianca?
I don't know. Maybe not so much for reproductive health, but it's actually an exceptionally important behavioural trait that exists within us. We wouldn't have evolved with it otherwise. It's basically so we can take risks. It's really, really important that, I decided to jump on a plane from Australia 7 years ago and come to Cambridge. I mean...
Is that a risk? I don't know. Is it?
Some people would say the weather's not very nice.
Well, that's true. With the weather
very
perspective,
risky.
It's very, very risky, Jess.
So if you start out with it and it's inherited from your parents, does it not change over the course of your life? So you're quite into taking risks when you're a teenager and up to your 30s maybe, and then you just don't want to take any risks anymore?
That's very true. So there's definitely, it changes over the lifespan. And you're right, during adolescence, it's at its highest. And this is when, people are very, very happy to go and do these crazy things.
Well, that solves that one, then. Thank you, Bianca.
From baffling British weather,
sideways spines of the vertebrae coming off here,
to looking at a cheetah from the inside out, games making their way to the clinic, and what to eat in your garden. The Naked Scientists In Short podcasts bring you a top-up of short, compelling science stories. Listen and download for free at nakedscientist.com/short or subscribe to Naked Specials wherever you get your podcasts.
Today on The Naked Scientist, we've got a panel of experts taking on your science questions. Still to come, what tricks do sperms have up their sleeves to make sure they win the great egg race? What makes a highlighter so bright and colourful? And can animals have accents like us humans? Now, speaking of animals, here's the next part of our quiz for this week. We want you to tell us what this animal is. We played you a strange noise earlier. That's the noises that they make. Clue 2. is between 50 and 90% of these animals have chlamydia. What are they? While you ponder on the prospect of those animals having chlamydia, and before we go on to any more questions, David, you mentioned at the beginning that you're part of a very exciting project. This is the Bepi Colombo project. So can you tell us a bit more about this? What is this? What's it going to do and why does it matter?
Well, gladly. Bepi Colombo is a joint European Space Agency, Japanese Space Agency mission to the planet Mercury. It's been in the planning for couple of decades now, and the launch has been delayed and delayed, but we're finally about to go. We should be launching on the 20th of October from French Guiana. The cruise to Mercury is complicated. It takes about 7 years to finally establish orbit around the planet, but when we get there, we've got 2 wonderful spacecraft. There's a British-built instrument on board one of them, which is an X-ray spectrometer, which will give us the chemical composition of the surface, but we'll be imaging it and studying it. It's in the thermal infrared, which has never been done, and the gravity field and the waves and particles around it. And it's a fascinating planet because it's the closest one to the sun, and it's very dense, so it's a very big core and a very thin rocky shell around it. And yet, despite the thinness of a rocky shell, it's rich in some volatile materials which we haven't properly identified. We can see places where the surface is moth-eaten, where it's just dissipating away to space. It might be sublimation, it might be some other process. The most recent volcanic processes have been explosive, so we've got volcanic gases escaping away violently, blasting big holes in the ground. And we shouldn't be that rich in volatiles, that close to the sun. There's a whole geological history which interests me. Other people are fascinated with the magnetic field. No other rocky planet than the Earth has a magnetic field. So there's a lot to learn.
How far away is it from here to Mercury, and how's it going to get there?
Well, Mercury orbits 1/3 as far from the sun as we do. Of course, its distance between the Earth varies depending on whether it's this side of the sun or the other side of the sun. But you can get to Mercury quite quickly if you don't want to stop. But we have a swing by of the Earth and 2 swing bys of Venus, and then 6 flybys of Mercury, each time passing it more slowly until eventually it catches up with us with such a small relative speed difference that we can get captured into orbit and start doing science from orbit.
You're going so fast to try and lose that velocity to slow down so you can approach Mercury at something other than sort of absolutely breakneck speed.
Absolutely.
That's the challenge, isn't it?
You're falling towards the sun as you leave the Earth to get to Mercury, so you're going so fast when you get there, unless you play these clever tricks.
Jess?
How long will it take for information to get back from Bepi Colombo to us?
Well, the information will get back quickly when we transmit it. The light travel time from Mercury to Earth is anything from about 6 minutes if it's this side of the sun to about 15 if it's on the far side of the sun. But we can't send all the data back in real time. We have to store some of it on board and transmit it back when we've got a large antenna pointed at the spacecraft.
When you actually get there, how long will the spacecraft survive around Mercury? Because the conditions sound horrendous.
The conditions are horrendous. On the day side of Mercury, you've got the sun with 10 times the power and a hot planet below you. So it's a difficult environment to operate a spacecraft. The design lifetime is a year. We're hoping for a 2nd-year extended mission. NASA's Messenger, which was there from 2011 to 2015, had a similar design lifetime, and it worked for 4 years in the end. We'll be very happy with 2 years.
If it survives for 2 years, how will this change our knowledge of Mercury? I mean, what's the number one thing we absolutely need to discover out of this mission?
For me as a geologist, it's what the heck are all these volatiles doing there? We haven't identified exactly what they are. We can tell they're volatile substances. They shouldn't be there if Mercury began that close to the sun. So we'll be finding out what's making the interesting recently active geological processes and where the blooming planet formed, because it may have formed further from the sun and found its way inwards. Other people will tell you it's a magnetic field and a reconnection events, because with 2 spacecraft we can measure the magnetic field at the same time at 2 different places and see these substorms going on. But there's a whole lot to learn. It's only the 2nd spacecraft ever to orbit Mercury and the 3rd one ever to visit. So there's an awful lot to learn.
And just briefly, when's it blast off? Where from? And how can we watch if we want to find out more?
It's launching from French Guiana in the very small hours of the morning on Saturday, the 20th of October. It'll be televised. Just look for ESA television on the internet. You will find it. There won't be much to show from the mission until we get into orbit about Mercury. We'll start doing science in 2026, which is a long time.
Thank you very much, David Rothery, who's part of the mission Bepi Colombo that you're just hearing about there. Now, Jess, here's a question for you. It's from Martin, who says, what is plasma? Do we ever encounter plasma in normal life? Now, Martin is not talking about the stuff wish-washing around in your bloodstream. He's talking about the fourth state of matter, I believe. So can you help Martin out?
I think he is talking about the fourth state of matter. So we're all pretty happy with solids, liquids and gases. But if we heat gases up even more, the atoms and molecules inside them start to tear apart and some of their electrons come off those atoms. And then you get left with this kind of sea of ions and also electrons on their own. And they're superconductive. And actually we do encounter the plasmas quite a lot. We have them inside a plasma ball, if he's ever seen a plasma ball, or we have them in the fluorescent tubes inside lights, or you even can get plasma displays for televisions now. So we do encounter plasmas a lot more often than you think.
David?
Yes, and the Bepi Colombo spacecraft will be studying plasma because the solar wind, the charged particles streaming out from the sun, are technically plasma, and there are plasma scientists that do a lot of work on space missions.
I've always wanted to ask Jess, a physicist, this. You know that the plasma balls that you see, actually, how do they work, and why does it love your hand when you put your hand onto them?
Because your hand is conductive, because humans are slightly conductive. So you have something at the centre of the plasma ball, which is called a Tesla coil. Okay. And then you have a noble gas around it. And as those electrons go into that noble gas, it excites Nobel gas. And obviously you've got Nobel prizes on the brain. And then you've got this plasma created inside this ball, and you get these kind of fingers that go out from the middle, from the centre of this coil, to your fingers if you're physically touching the side of the ball because you're partially conductive.
Well, I thought it was just my attractive electric personality.
You're also very attractive, but that's a different story.
Well, talking of attractive, from attractiveness to spirituality, thank you for that, Jess. Can you help us with this one, please, Jacob? Because David has commented on our Facebook page. That's nakedscientist.com/Facebook to get there. He says, could the other great apes become spiritual on their evolutionary trajectory? In other words, as they evolve in the same way that humans have evolved to embrace sort of God and that kind of thing and spirituality, could other great apes do that, or have they indeed done that already?
So this is a really good question. The first thing I would say is that species don't have an evolutionary trajectory as such. I think it's historically been a very dangerous idea that species evolve towards some kind of direction and some goal. And that really stems out of the kind of Aristotle idea that there's a great chain of being and that humans are at this top of this very complex ladder and everything's evolving to become more complex. We now know that in evolutionary biology, actually, it's not the case that species are usually evolving to become more complex. Actually, most species are evolving to become more simplistic. The next question is what we mean by spirituality. And there's been a lot of research on the evolution of spirituality in humans and whether it's been positive for humans. In other animals, the only case that I know of is a very well published in the media recent paper of chimpanzees. What these populations of chimpanzees were doing, they'd been studying them for quite a long time, and they'd seen that they picked up rocks and threw them into rivers and waterfalls and so on. That had been observed for quite some time, and nobody really ever understood it. And then just in 4 populations of chimpanzees, they observed that they were picking up these stones and either placing them or throwing them at just certain trees and filling crevices within the trees. And nobody understands why they were doing it. There doesn't seem to be any relationship to any kind of, foraging, or there's no rationale behind it. And the primatologists that published this paper call it this sort of ritualized behavior with no real explanation. It's just kind of a culture that's evolved in these populations of chimps. The media, particularly some well-known newspapers that tend to exaggerate things, called this, do chimpanzees believe in God? I think it's a load of nonsense. But.
We had Lee Berger on this programme from South Africa who discovered recently Homo naledi, this kind of Homo species. It's a relative of ours, but smaller-brained, brain the size of roughly a human fist, adult human fist. These, what would have arguably been quite primitive creatures, which were around until quite recently, maybe 100, 200,000 years or so, they were burying their dead, it would appear. They were going to extraordinary lengths, actually, to take their dead to a cave. So this argues that maybe there is something ingrained in how we primates have evolved to want to believe in I don't know, maybe afterlives or sort of special spiritual treatment of the dead and so on. Do you think?
Yeah, I mean, there's a big difference between burying your dead, which is just a sensible thing to do if you don't want to get sick, and doing it in a ritualized way. So
But they were clearly doing this in a ritualized way.
Sure, yeah, and we know that Neanderthals, for example, also they marked these graves in special ways that suggest that they weren't just burying their dead for sanitary reasons. And we know that elephants too, you know, when their family members die, they go back to the bones and they touch them and they feel them. And other animals carry around their dead. Chimps and dolphins carry around their dead for a long time before they let them go. These are, you know, they're advanced ways of thinking, reflecting, but I think there's a big jump between these kinds of reflections on what's happened in the past, temporal memory, and spirituality and religion.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
You're listening to The Naked Scientist with me, Chris Smith, and with me, our panel of experts who are taking on your science questions. Bianca Jupp, David Rothery, Jess Wade and Jacob Dunn. Between them, they cover neuroscience, space science, physics and geology. Quite a selection there. And we have a question for you at home listening. We're trying to guess what or who this is. First, we heard the noise they make. Then we learned that these animals have very high levels of chlamydia, and clue 3 is, when they overheat, they hug trees to cool down. Can you guess what they are? Final clue coming up later. First though, time to quiz our panel. We're going to divide our panel members into 2 teams. We'll have David and Bianca, and we'll have Jess and Jacob. And round 1 is elementary, my dear. David and Bianca, you may confer. Your question: which chemical element shares its name with half of a Belgian reporter and something that you would put food into?
My
Belgian
goodness.
reporter?
I don't listen to Belgian radio.
The only Belgian I can name is Hercule Poirot, and he's fictional. It's something that you put food
Let's
into.
think about like bowl, plate. I have no idea.
Most of the elements are named after towns in Sweden. I think we're beaten, aren't we?
Like,
Tupperwarium. It's not
no.
That. No, it's not that. I'm just kidding. But I'm going to have to hurry you. Do you know what you want to guess?
Boron.
No, I'm afraid it's not. The answer's tin.
Oh,
the
my
Belgian
goodness.
reporter, tin.
Oh,
We did say half of a Belgian reporter. There we go. Jess and Jacob, they scored the premium score of 0 for that. Jess and Jacob, which element is also a place in Kentucky? It's also the notional home of Superman.
Where is Superman from? Oh my gosh, we should know this.
There's only 120 elements on the periodic table you can pick. So.
And you know it. This is not
these
fair.
guys over here are crowing because they know this one.
Oh, is
Know where
it?
Batman's from? Does that help? Gotham City?
Okay, no, that
Gotham
doesn't
Birmingham.
help.
Doesn't really.
I don't know.
They're going to guess? Wrong. Okay. David, put them out there misery.
On Earth, he lived in Smallville, but he came from Krypton.
He
Krypton,
did,
but I
yeah.
didn't want to say something stupid.
He did. Krypton, the Nobel gas. Noble gas. I
See,
caught
everyone's
it from,
addicted
caught
to
that
this.
meme from you, Jess.
Nobel
It's a
week.
noble gas. It's used in fluorescent lamps, of course.
Okay.
Round 2. This round is the elephant in the room. You have to guess the species. So, David and Bianca. Elephants are unfortunately hunted and killed for their ivory tusks, but it's not just elephants that have ivory. Can you name one of the other species, please?
The narwhal.
Narwhal.
Yeah,
Yeah.
we both, you say it.
Narwhal.
Bing bong, yes. The narwhal was one of them. You could have had actually any of these whales. Walruses, hippopotamuses is not a whale, of course, but it's almost like a whale because it's the closest living relative of a whale. Also sperm whales, killer whales, and mammoths. Flourishing trade in mammoth ivory, actually, would
And
you
they're
believe?
not an endangered species.
No, but they have come off
Anymore.
less well from the process of evolution, though. They're not around anymore. Warthogs also have ivory. So that's +1 to you. Well done. David and Bianca into the lead. Jess and Jacob, humans go through the menopause, and we're one of only 5 species to do this. Can you name one of the other 4, please?
Yes, Jacob can.
Jacob.
Killer whales and a few other different kinds of whales too.
Oh, you're absolutely on
Nailed
fire. So I'll give you one of those. It is whales. You could have had short-finned whale, killer whale, beluga whale, and the narwhal. Sorry, David.
Do whales have hot flushes?
You wouldn't know because they live in cold water. But it's interesting that none of our closest primate relatives, like chimps, everyone thinks chimpanzees, that kind of thing, they think they do, but they don't have a menopause. Good. Right, so that's 1 each. So you're level pegging. Here we go into round 3. So who's going to win? We'll find out. This is called Watch This Space. David and Bianca, Betelgeuse is one of our galaxy's largest stars. You can see it at night. It's the brightest star in Orion for any would-be astronomers out there. What would happen if you tried to use our asteroid belt as a belt for Betelgeuse? Would Betelgeuse's trousers fall down? Would it be a perfect snug fit? Or would it be an impossible squeeze? What do you think?
Betelgeuse is a red giant.
Yes.
It's going to be somewhere near the asteroid belt. I suspect beyond the asteroid belt.
You're going for the perfect fit or the impossible squeeze?
The impossible. Betelgeuse would stretch further than the asteroid belt.
Yeah, absolutely. It's enormous. The radius of Betelgeuse is 820 million kilometres. The asteroid belt's just 300 to 400 million kilometres out from the sun, so it would be so tight that it would sort of constrict Betelgeuse in the middle if it tried to wear our asteroid belt. The Kuiper belt might be more appropriate. I think that's a bit further out, isn't it? Okay, thank you very much. So +1 for that. Okay, you got to get this one right, Jess and Jacob, to stay in the game. Which of the following types of planet has never been discovered? David knows the answer to this. You're not allowed to cheat, David. Which of the following types of planet has never been discovered? A planet the shape of an egg, a planet that orbits a star that orbits a star, or a planet that rains diamonds? What do you think it is?
Oh, man.
I mean, is the last one just so ridiculous that it's just a red herring?
I mean, they're not going to be massive, beautiful diamonds that you'd wear on a ring, but you could get some kind of carbon structure that rained from something. I have no idea.
I think Dave should
planets.
send a mission there and just bring back a load of diamonds.
It would be a wonderful thing. I think it might take more than 7 years.
So what are you going for? The egg, the orbit of a star within a star, or around a star, or a planet that raining diamonds?
Egg.
Okay, let's go with egg.
You're going for egg. +1 as well. Oh, now we're into tiebreaker time. Okay, so this is it. Right, yes, the answer is A, that a planet shaped like an egg has never been discovered, but diamonds do rain down on Jupiter and Saturn, potentially, and there are also plenty of binary star systems that have planets. So you could end up with a planet that orbits a star that orbits a star, so that one's possible too. Right, tiebreaker time. This is everybody. You confer between the two of you, and your pairs obviously, and the team that gets it closest is going to get the point. So if one of you drank all of the alcohol that's consumed in one day in the UK, and assuming you didn't die, and it does take you 1 hour to process 1 unit of alcohol, how many years before you were sober, do you think? Off you go.
Addiction question.
We've got an addiction scientist.
How many units do people drink a day?
Okay, so there's how many people in the UK and how many units on average do you think people?
60 million. And
okay, I've just heard there are 60 million people in the UK.
50 million units.
20 million hours
per day.
20 million hours.
Yeah. Okay.
Which is how many years?
Have we got an answer? So let's come to Jess and Jacob first. What do you think the answer is? We'll take it to the nearest. We'll take it in years. What do you think the answer is?
2,500 years.
They're going 2,500 years. David and Bianca, what do you think?
We're going higher.
Yep.
Should we stay with about 8,000 years?
Actually, the answer is 13,000 years.
Goodness.
So David and Bianca have it. We reckon it would take 13,000 years. It's estimated in the UK we drink about 110 million units a day each. No, not each. As a country. It would take about 13,000 years to process that. So this week's winners, big round of applause.
Well done.
David and Bianca are the Naked Scientists' big brains of the week. Now, back to our questions. David, can you answer this one for us?
Are new planets still forming?
What do you think, David? That's coming from Elisa. Can you tell us, first of all, how a planet gets born, and then tell us if they're still being born?
Planets, we think, form from gas and dust surrounding a young star, and it gradually comes together in bigger and bigger lumps, and you get a series of collisions. And so planets are not forming in this solar system anymore, but we now know that at least half the stars in our galaxy have planets, and the young stars among those still have, are still very young and still have clouds of gas and dust around them. And we can see gaps in the dust rings round these young stars where we think there are planets that have formed and cleared the dust away. So planets very much are forming around other stars at pretty much the same rate at which stars form, which is a few new stars every year in our galaxy.
Fabulous. David, thank you very much for that one. Jacob, here's one for you from James, who wants to ask you about sperms.
When sperms race towards an egg, is it just a case of which sperm is the fastest swimmer, or do they have tricks up their sleeves, like some sort of gamete wacky races?
Gamete wacky races, the mind boggles. But what do you know about this?
Well, that's a brilliant question. I don't know how long I've got, but I could talk about sperm for a long time. Right, sperm don't have sleeves to start with, but they do have all sorts of amazing tricks if they did have sleeves, and they would be up them. So to start with, in lots of species, there are different kinds of sperm tricks evolved, but particularly in those species where multiple males breed with the same female, because then the kind of level of the evolution shifts, the level of the selection shifts to the sperm, and then it's all about who gets there first. So in those species, we tend to see that the males have much bigger testes, so they can produce more sperm. So it's more likely just by sheer chance that the sperm from a given male beats the sperm from another male. But they also may evolve faster sperm. They also evolve to have special enzymes, chemicals that kill off the sperm of other males. So if there's the sperm of more than one male in the reproductive tract of the female, the chemicals kill off the other sperm. And lots of other amazing things. But for example, there are special enzymes that form what's called a copulatory plug. So a male copulates with a female, and then basically this plug forms, sealing off the female reproductive tract so that no other male can produce with her afterwards. Even the shape of the penis is thought to have evolved for this kind of chemical warfare. So the human penis, for example, the gland on the end is thought that it's perhaps evolved so that it can pull out sperm from other males from inside the female. But that's not to say that females are kind of just waiting for this fantastic sperm to arrive. By no means is that the case. The egg is very active in this process, and females are very active in this process as well. Females have evolved brilliant strategies in some species to be able to eject sperm or store sperm and essentially choose sperm from the right male to fertilize the eggs, and other kinds of behaviors, so selectively, for example, to abort a fetus if it's not from the right male, and various other tricks. So it's a really, there are textbooks about this kind of sperm competition and what's called cryptic female choice. It's a fascinating area of evolutionary biology.
Thank you very much, Jacob. It certainly is fascinating. I learned recently that bees actually can store sperm for years and years and years.
Yep.
They mate once in their life,
Yep.
and they use this stored sperm for years to produce all of their offspring. It's a fascinating thing to learn about.
Absolutely. Lots of insects store sperm for very long times, and from lots of different males sometimes too.
So they can take their pick.
Yeah, exactly.
Thank you very much. Now, Jess, we've got this question from Cam, who highlighted this issue for us, who says, why are highlighters so bright? How do they work?
This is a really great question. I think we're familiar with most chemicals are colourful because they absorb some colours of light and not others. But in highlighters, there are special dyes that particularly absorb in the kind of ultraviolet part of the spectrum. And they do that because they've got a bunch of atoms in there that have alternating single and double bonds, and we call those things conjugated. And they're exactly like all the materials that I work on, actually. And these dyes that absorb in the UV part of the spectrum, sometimes those little electrons absorb that kind of light, jump up, just like the lasers we were talking about before, and then really quickly aren't very happy up there and jump down and fluoresce. So the highlighters actually contain a small amount of these fluorescent dyes, and you can get these fluorescent dyes in all different colours, which gives us all the different colours of highlighters.
Which is very nice indeed.
Beautiful.
Isn't it? Science in action. Thanks very much, Jen. Not you, the highlighters, but your science in action as well. Well, now it's time for the last clue for our Who Am I quiz. The scientific name is Phascolarctos cinereus, which loosely is translated as ash grey pocket bear, which is a misnomer, actually, because they're not actually bears at all. So, can any of our panel answer this? Well done if you got it at home, by the way. I would hope that Bianca knows what this is, given her heritage. But what about the rest of the panel? Does anyone else, before we give the game away, know what this is? Jess, what do you think?
It's a koala.
It was indeed a koala. Yes, and 90% of them are affected with chlamydia. Jacob, just briefly though, because I have one more question.
So they've evolved this amazing evolutionary trick. So koalas are the only species that we know of that have evolved a second pair of vocal folds. So they don't just vocalise with their throat like all other mammals do, but on their velum, which is the soft palate, they have a second pair of vocal folds. So even though they're tiny animals, they make this really low frequency sound, which is really unusual.
Can you do a koala?
Well, it's really like a howler monkey, like a...
That sounded more like a toad.
Yeah,
or
it did.
frog.
It sounded a bit like a cricket,
you
didn't
need
it?
To
A really
that
macho
one.
cricket.
Yeah, but that wasn't bad, though. Good job we got a recording of it, I guess, isn't it? Thanks very much, Jacob. Now, we just asked Georgia, who's producing the programme, to pop in for a minute because you have a particularly personal question you want to ask Bianca about something very close to your heart. Booze.
I do, as we have an addiction specialist, and I thought, this will help. I tried Stoptober again, and just like with Dry January, the same thing happens every time I give up alcohol. I start drinking all kinds of fizzy drinks, eating lots of chocolates, and I seem to replace one vice with another. Is there a neuroscience reason behind this, and can I save my liver without becoming fat? Definitely. Everyone needs a vice, Georgia. So this gets back to this idea of this neurochemical that I was talking about before, dopamine. So every time you do something rewarding, And when you take drugs, you get this hit of dopamine that goes on. And presumably when you drink, you do it maybe at a certain time of day. Maybe when you get
in the
home,
evening,
when you
just
get
for
home,
all,
when
so
you get
all the listeners know.
Not first thing in the morning. When you get home from work, for me, it's if I've had a particularly stressful day, or my experiments failed. I'm particularly a big fan of crying into a beer. So the brain essentially becomes expectant of this dopamine hit that it's going to get. It's going to say, "Okay, I finished work. Now I want to drink," but it doesn't happen. So beyond dopamine signalling this reward, it's also good at, it's involved in signalling the prediction of reward, whether or not it's more or less than what it's expected. It's a bit like if you go to your vending machine and you put your pound in and you get your chocolate bar, but all of a sudden 2 chocolate bars come out and you're like, oh, whoopee, this is amazing. In the same way, if you put your pound in the vending machine and then you don't get a chocolate bar, you're like, oh no, that's really terrible. And this happens, it's reduced dopamine. So yes, essentially this is what's happening. So your brain's looking for its hit of dopamine, and so you're filling it with other things that are rewarding. So fizzy drinks, chocolate.
I'll try and find satsumas more rewarding then.
Okay, maybe go for a run.
No, my friend who gave up smoking said he then developed an addiction to chocolate bars instead, and then said instead of fighting the risk of lung cancer and heart disease, he's then fighting the risk of diabetes instead. So it's like robbing Peter to pay Paul. Bianca, thank you very much. Jacob?
I was just wondering if we over-abuse that, and some people do, can we run out of dopamine in our lifetime?
No, it's constantly replenished, like all neurotransmitters, but it's actually something that we do see in addiction. We have with different levels of dopamine. So there's the receptors actually for dopamine are actually reduced in addicts, and so this may be why they're able to take more drugs. They need more drugs to get the same effect. And the question is this a cause or effect? Is this because people have been smashing their brain with lots and lots of dopamine, or is it actually a pre-existing deficit? And maybe this is the reason why they take drugs in the first place.
Is not part of the come down when people have taken a drug of abuse that mobilises lots of these nerve chemicals? I'm thinking of things like cocaine. Now, I know that doesn't work on dopamine. It generally affects things like serotonin, doesn't it, cocaine? It pushes the levels up very high in your brain. It displaces lots from the ends of these nerves. Don't you then end up with a depletion for a little while, and that's why you feel bad afterwards, why you replenish?
Cocaine actually is a dopamine reuptake inhibitor. So
it does boost dopamine as well.
Yeah.
But it's going to leave you feeling robbed of dopamine
yeah,
for
so,
a while.
I mean, people love to talk about terrible Tuesdays after a big weekend on cocaine. And you definitely see a depletion. But it resolves over time.
You'll be all right by Wednesday. Yeah. Now, Jacob, we've got this question here from Sam, who wants to know, do any other animals, apart from humans, have regional dialects? We know that humans speak regionally. They have accents and things as well. Do animals do this?
So I'm happy to do a howler monkey and a spider monkey on national radio, but there's no way I'm attempting any kind of a regional accent. In short, yes. There are 2, I guess, different ways that we can explain this. In lots of animals, any given species will have a pretty limited repertoire of sounds that they make. So a species will make a grunt and a click and a sneeze or whatever it might be, and they're the 3 sounds that they might make. But even though their repertoire is limited to just a few sounds, in different places, those individual calls might sound slightly different. So that would be evidence for a kind of regional accent, even though it's within the same sound. So I say a word one way and somebody in Newcastle says it a different way and somebody in Birmingham says it slightly different, but we're saying the same word. So that's kind of a regional accent, if you like. And there's lots of evidence for that in birds and mammals. And it seems that this can even be predicted by genetics and there's some element of learning.
Weren't scientists at St Andrews showing that marine mammals have regional accents that differ globally?
This is where it gets really interesting because some animals, and there aren't that many, can actually learn new vocalizations. So their repertoire is not limited just to these few sounds that they make. And marine mammals, particularly some whales, are very, very good at this, and seals can do this too, and elephants. And songbirds, of course, do this all the time. So famously, lyrebirds and so on can just mimic any sound. And so they can learn these new sounds, and that's a sort of next level of complexity. They can have in different places of the world very, very different, not just accents now, but it's almost like they have different languages because they're capable of this vocal mimicry. What's really interesting for me, because I study non-human primates and I'm interested in the evolution of speech and language, is that humans are the only primate that are capable of learning new sounds. All the other primates have an innate, limited repertoire. And what we've seen fairly recently, in fact, my colleague and I published something on this fairly recently, is that this seems to be related to neuronal control over the speech apparatus. And the other primates don't have this kind of fine level of control that's needed in order to learn new sounds.
So at the moment, it's just us. That's good. No competition here on the radio yet. There are no monkeys for presenters yet, although it sounds like it on some radio
stations. Yeah, but you need to keep up the good work, Chris.
Thanks very much, Jacob. Now, David, we've heard from Craig, and Craig wants to know, is there a limit to how big a rocky planet like the Earth can be? And also, is there a size limit on planets just in general?
Yes, there's a limit to both. It's really a mass limit rather than a size limit. We're discovering exoplanets round other stars, and in the cases where you can see both their size because they pass in front of a star and their mass because they disturb the star's position, we can pin down the size and mass of these bodies. There are bodies that are about the right density to be rocky planets, up to about 10 times the Earth's mass. So from 100th the Earth's mass up to about 10 times the Earth's mass, you can have a rocky planet. Bigger than that, Jupiter's 300 times the mass of the Earth. If you get up to about 13 times the mass of Jupiter, we don't regard a thing as a planet anymore, because at 13 times Jupiter's mass, the pressure inside that body is going to be sufficiently high that the heavy form of hydrogen, deuterium, can be fused together and you can have deuterium fusion. And it will be a sort of a star called a brown dwarf, not a proper star fusing hydrogen, common hydrogen. To do that, you have to be about 80 times Jupiter's mass. So that will be a real star. But certainly 13 times Jupiter's mass upwards, it's not really a planet. And the rocky planets have to be smaller than that. And in between, we've got ice giants like Uranus and Neptune, and a bit smaller than that, not exemplified in this solar system. We think of water worlds, bodies which have a lot of rock but surrounded by water, so very deep oceans.
So that would be quite an interesting place to go surfing, wouldn't it?
No, because it wouldn't be a beach. So there's nowhere for the waves to break. So you could bob up and down and sail around them, but you wouldn't surf.
How much pressure would the water experience? Is it possible to get a planet that's got so much water, such a deep ocean, that the pressure is so high that the water would actually turn to a solid at the bottom of that ocean?
There are various high-pressure forms of ice known. And you don't need that terribly high pressure to do that. One of Jupiter's moons, Ganymede, it's the largest moon in the solar system, has ordinary ice one at the surface. Below that, it has a layer of liquid water. And below that, we've got higher pressure forms of ice there. So the right temperature conditions, you don't need a very strong gravity field to get you into these high pressure ice forms.
Fascinating stuff. Thank you very much, David. Now, Bianca, we're getting our money's worth out of you this week because Fran's been in touch and wants to know what science can tell us about ways to quit smoking. Can you help with this one?
Okay.
Big question, this. This is a multi-billion-dollar industry.
Definitely. And yeah, quitting smoking is definitely a worthy and good thing to do. But fortunately, tobacco seems to be one of the addictions we seem to be reasonable at treating. But it's also really important to recognise, again, getting back to this idea of that most of us actually aren't vulnerable to addiction. So people being able to just quit smoking willy-nilly could just potentially be that they're not actually addicted. They're dependent. Yes, you have the withdrawal effects, but you're not actually addicted. And so you manage to, for whatever reason, grow out of your addiction and stop.
Can I clarify something then? Because that was very interesting what you just said. You said most of us are not vulnerable to addiction. So roughly what proportion of the population are there?
So it's between 12 and 20% of the population who use drugs who ultimately go on to develop addiction.
So you'd call them high risk of addiction type people?
Yeah.
Okay.
Definitely.
And so if you focus on those, what can say you're in that 20%, which is interesting you say 20% because that's roughly the proportion of adults in Western countries that smoke, isn't it? So they're probably the high risk of addiction type people, aren't they?
Exactly.
So what can you do to help someone who finds themselves in that high risk bracket and they're a smoker? What can they do to stop?
Yeah, so essentially when you stop smoking or stop whatever your vice happens to be, you're looking for this dopamine hit. You're craving, as they say. And so you're used to getting this through your hit of nicotine. And what most people use to come off it is this nicotine replacement therapy. So this idea of gum or even now these electronic cigarettes. And what that is doing is kind of replacing that hit of dopamine with another form that's potentially less harmful. So it's a harm minimisation strategy.
And is that effective? Do you think, is that the best way of nailing the habit?
Yeah, so it definitely works for some people. And I think the biggest criticism that comes out of these sort of studies looking at this is that people don't take enough nicotine replacement therapy or for long enough, so they eventually relapse, and it's a very slippery slope. But amazingly, the brain is very plastic and works like a muscle. So every time you manage to resist having a cigarette, your ability to be able to resist having a cigarette gets stronger. And so in this way, NRT, or nicotine replacement therapy, is one way to do it. So the other therapeutic that we have that works exceptionally well is called Champix, or varenicline. And that works on basically blocking these nicotine receptors within the brain. In blocking them, it actually stimulates them, so you get your hit of dopamine. But also amazingly, because it sits in the receptor, anytime you do happen to have a cigarette, if you do relapse, you don't get that same hit. So it's not rewarding anymore. So it's like flexing that prefrontal cortex and getting better at being able to inhibit that craving. And yeah, so it's actually been an exceptionally useful therapeutic. Unfortunately, it does have some side effects. People report having really crazy vivid dreams. And yeah, so it doesn't work for everyone, unfortunately. But yes, that's currently the best way to go about this.
Bianca, thank you very much. Well, there we must leave it. Regrettably, the arrow of time has defeated us. But thank you very much to our panel, who are Bianca Jubb, David Rothery, Jess Wade and Jacob Dunn, for answering your questions. And thanks also to Georgia Mills, who put the programme together. Do join us at the same time next week, when we're going to be going back to the time of the Neolithic to find out how some of our ancient ancestors lived and how they invented one of our favourite drinks. Also an addictive one, I'm afraid. This time, it's wine. The Naked Scientist comes to you from Cambridge University and is supported by the EPSRC and Rolls-Royce. I'm Chris Smith. Thanks for listening, and until next time, goodbye.